You knew that app you use every day? Ever stop to think about how it actually works? Behind that smooth interface, there's a constant, high-stakes conversation happening between hundreds of tiny services. And if just one part of that conversation stumbles, the whole thing can come crashing down. So today, we're going to crack open the architect's playbook and learn the master moves they use to build systems that just refuse to fail.
All right, here's our game plan. We'll start with the basic rule of engagement, the digital handshake. Then we'll meet our main characters, the server, and the client. After that, we'll face the villain of our story, the dreaded cascading failure. And finally, we'll reveal the architect's safety net, the secret weapon that keeps everything running.
Okay, first things first. Before any two services can talk, they need to agree on the rules. And for pretty much the entire web, that comes down to one simple, powerful model.
At the heart of everything is this idea, the HTTP request-response model. The best way to think about it is like walking into a store. You, the customer, are the client. You're proactive. You walk up to the clerk and ask for something. The store clerk is the server. They're reactive. They just stand there waiting for you to make a request. They don't do anything until you ask. This simple back and forth is literally the foundation for how the internet works.
So let's talk about that store clerk, the server. In the world of Python, a super popular way to build one is with a framework called Flask. Think of it as our waiting host, ready to whip up whatever's ordered from its digital kitchen.
So what does Flask actually do? Well, its main job is to listen. It uses this thing here, the @app.route decorator, which is basically like putting a sign on a specific door. When a request comes knocking on the URL for /book, Flask sees that sign and knows exactly which piece of code, which function to run. It's a super clean way to direct traffic to the right place.
Of course, a waiting host is pretty useless without a guest, right? So now we flip the coin and look at the other side of this handshake, the client. This is our proactive guest, the one who actually gets the party started. Now, in a microservice architecture, this is where things get interesting, because services are constantly talking to each other. So one service will put on its client hat to go ask another service for information. A go-to tool for this in Python is the requests library. With a simple line like request.get, one service can proactively go knock on another's door. This is the engine that drives all the communication.
So we've got our players on the board, the waiting host and the proactive requester. They're shaking hands, data's flowing, it all sounds great. So what could possibly go wrong? Well, this brings us to the hidden trap, the thing that keeps architects up at night, the cascading failure.
This question seems so simple, but in a distributed system, the answer is terrifying. Everything is connected. Everything depends on everything else. So what do you think happens when just one tiny link in that chain starts to drag its feet?
Let's paint a picture. Service A needs something from Service B, but Service B is having a bad day. Maybe its database is slow. So what does Service A do? It just waits. But what if Service C was waiting on Service A, and Service D was waiting on Service C? You see the problem. You get this massive digital traffic jam, all because one car tapped its brakes.
And that right there is the cascading failure. It's a domino effect. As each service waits, it holds on to precious resources, memory, connections. Pretty soon there are no resources left and the whole system just grinds to a halt. It's an architect's absolute worst nightmare, and it all started with just one slow component.
So how do you stop this nightmare scenario? Well, you don't just hope for the best. A good architect designs for failure. They build a safety net. Let's look at the 3 critical moves from their playbook to prevent this kind of disaster.
Move number 1 is arguably the most important, this circuit breaker. Just like the circuit breaker in your house, its job is to trip and cut the power before a surge burns everything down. In software, this means we have to fail fast, and our main tool is deceptively simple, the timeout parameter. When making a request, an architect will always add timeout equals 1. This tells the request, you have 1 second to get a response. If you don't, give up. This one tiny setting prevents a slow service from ever starting that domino effect. It's not just a nice to have, it is absolutely non-negotiable.
Okay, for our next move, you're going to have to bend your brain a little. We need to completely rethink what an error means. I'm going to ask a weird question. Can a failure actually be a success?
Check this out. It's all about perspective. A developer sees a 400 bad request, and their first thought is, crap, I have a bug. But an architect might see that same 400 and think, perfect, it worked. Why? Because a 400 often means the system correctly enforced a business rule.
Say you tried to create a user with an email that's already taken. You want the system to reject that. That 400 response isn't a failure of the code, it's a success of the business logic. It's the system acting as a gatekeeper, and it's doing its job perfectly.
All right, on to our final move, and this is some truly next-level thinking. We want to build clients that aren't just safe, but are also incredibly flexible. This is where we use something called the command pattern, and it's beautifully simple with the requests.request function.
Now, let's slow down here because this is so powerful. Normally, you'd write code like requests.get or requests.post. The action is hard-coded, but with requests.request, the action itself, get, post, delete, is just a string you pass in as a variable. You've abstracted the action, so what does that get you? It means you can write one single, elegant function that can talk to any service using any method. Think about that. A new feature requires a new endpoint tomorrow? No problem. You don't have to rewrite your client code, it's already smart enough to handle it. This is how you build systems that are future-proof.
So, let's bring it all home. We have Flask, our patient waiting host, and the requests library, our proactive guest. But the real keys to the kingdom are in the architect's safety net. Using a timeout as a non-negotiable circuit breaker, shifting our mindset to see a 400 error as a successful defense of our business rules, and finally, using the command pattern to build clients that are ready for whatever the future throws at them. That's how you build systems that last.
So I'll leave you with a challenge. Think about the system you work on right now. I want you to find that one silent conversation, that one place where two services are talking to each other without a circuit breaker. Which part of your app is just one slow response away from bringing the whole thing down? Because finding that weak link, that's your first step to thinking like an architect.